Hello everyone! In this class we will study the determination of soil alkali hydrolyzable nitrogen. Nitrogen is one of the essential nutrient elements for the growth and development of nitrogen plants, and one of the three elements of fertilizer. Nitrogen deficiency has great impact on crop growth and yield. Soil alkali hydrolyzable nitrogen can directly reflect the ability of soil to supply nitrogen. Measuring soil alkali hydrolyzable nitrogen can provide theoretical basis for rational distribution and application of nitrogen fertilizer. Let's introduce it from several aspects. Determination of soil alkali hydrolyzable nitrogen. Firstly, based on the principle of soil alkali hydrolyzable nitrogen determination. 1. 0.8 moles per liter of sodium hydroxide was used to alkali hydrolyze the soil sample so that the available nitrogen was converted into ammonia gas, which was continuously diffused and escaped to be absorbed by boric acid, and then the content of alkali hydrolyzable nitrogen was calculated by titration with standard hydrochloric acid. Next, let's see what equipment we need to prepare. 1. Instruments and appliances, semi-micro burette, diffusion dish, incubator, titration table, glass bar. 2. Reagents. 1. 0.8 moles per liter sodium hydroxide, 2% boric acid solution, 0.01 moles per liter hydrochloric acid, nitrogen determination mixed indicator, special glue, ferrous sulfate powder. 3. Samples. Air-dried soil sample, knowing the principle of measurement and preparing instruments and appliances. Let's begin to operate. Weigh samples. Weigh 2.0 grams of air-dried soil sample passing through a 1 millimeter sieve. Add 1 gram of ferrous sulfate powder. Mix evenly and place it in a clean outer chamber of the diffusion dish, and gently rotate the diffusion dish to evenly pave the soil sample. 2 copies of the same sample should be weighed for parallel determination. Prepare for diffusion. Add 2 milliliters of 2% boric acid solution and a titration nitrogen mixed indicator in the diffusion dish chamber. Coat special glue on the outer edge of the diffusion dish. Cover the frosted glass sheet and rotate it several times to completely bond the periphery with the frosted glass. Slowly push open the glass while exposing a slit in the outer chamber of the diffusion dish. Quickly add 10 milliliters of 1.8 moles per liter sodium hydroxide solution. Immediately cover the ground glass level and gently rotate the diffusion dish to fully mix the alkali liquor with the soil. Constant temperature diffusion. Gently rotate the diffusion dish horizontally to fully mix the solution with the soil. Carefully fix the ground glass by crossing 2 rubber bands in a cross circle. Then put it in a constant temperature box at 40 degrees Celsius for 24 hours and take it out. It can be observed that the solution in the inner chamber is blue. Titration. Use 0.01 moles per liter hydrochloric acid standard solution to titrate the solution in the inner chamber with a semi-micro burette. The titration end point is from blue to reddish. Write down the volume consumed by the hydrochloric acid standard solution. At the same time of sample determination, do a blank experiment, except that no soil sample is added. Other steps are taken to determine the same sample. Result calculation. In the formula, V, the volume of hydrochloric acid consumed when titrating the sample. V0 is the volume of hydrochloric acid consumed during titration in blank experiment. C is the concentration of hydrochloric acid standard solution. 14 is the molar mass of nitrogen. The third power of 10 is the mass conversion coefficient of nitrogen per kilogram of sample. M is the quality of dried soil samples. That's the content of this lesson. I believe that through the study of this course, you now have a certain degree of mastery of the determination principle and operation steps of alkali hydrolyzable nitrogen. That is the end of the class. Thank you for watching.